Hello class, in today's video we're going to be looking at factorizing non-monic quadratic trinomials. The learning intention of this video is we're going to understand the relationship between expansion and factorization for binomial products, and lastly we're going to know and be able to apply the process for factorizing non-monic quadratic trinomials. So the first thing I want to go through is just defining again what is a non-monic quadratic trinomial. So quadratic trinomials are pretty much any quadratic expression that consists of three terms, okay? But this could be further classified either as a monic quadratic trinomial or as a non-monic quadratic trinomial, okay? And a monic, this prefix like a mono, that just means it's one, so therefore the coefficient in front of the x squared term over here is going to equal to 1, whereas anything that's considered to be non-monic doesn't have a 1 in front of x squared. So these are some examples over here, as you can see. Now, there are many various ways that we could actually factorize non-monic quadratic trinomials. Previously in our last lesson, I kind of showed you that some of the non-monic quadratic trinomials can be factorized by taking out the highest common factor. So for instance, if this was our non-monic quadratic expression, notice that there is a common factor that we could actually remove from this expression. In this case over here, the highest common factor is equal to 5. So I could actually factorize it into something like this, and then I could then use the product sum method to actually factorize this part even further, which will therefore be equal to this over here, okay? But I do want to emphasize that this technique is not always going to be applicable, because you are going to encounter some expressions where there isn't actually a common factor within the actual term at all. So for instance, these ones over here, they all have a common factor where you can easily factorize, whereas on my right hand side of here, all the expressions, you can kind of say that there is no common factor that you can actually remove to factorize it. So in today's lesson, I'm going to show you one of the ways that we could actually go about this. Now, the way that we actually do this is by actually like combining both the grouping method as well as the product sum method as well. This particular method over here, I'd say it's relatively unpopular. It's something that I'm not really too familiar with myself when I was actually a high school student. There's other ways that I prefer to factorize, but in today's lesson, I'll show you how this particular method actually works, okay? So how do we actually factorize these non-monic quadratics by grouping? Well, remember that when we're trying to factorize through grouping, what we were essentially trying to do is we were trying to find a common binomial factor so that we could actually remove that out and then factorize it, okay? And we previously stated in the last lesson that this grouping method only works when you've got 4 terms, okay? So in my example that I've showed you in the last lesson, x squared plus 5x minus 2x minus 10, the way this works is we try to factorize like the first 2 terms together and then factorize the last 2 terms together, okay? So in this case here, there is a common factor within my first 2 terms. It's going to be x, whereas the last 2 terms, the common factor is going to be 2. So therefore, I could factorize that something similar to this. And once I factorize the pairs, each pair, you'd see that there is now a common binomial factor, okay? So x plus 5 is the binomial factor, so a factor that contains 2 terms. So therefore, if you were to factorize this successfully, therefore this would be what our answer is going to be, okay? So when we're going to be looking at non-monic quadratics, okay, because non-monic quadratic trinomials consist of 3 terms, the way that this works is we try to pretty much from those 3 terms, we use the grouping method by making that expression have 4 terms, which is why I said this is very similar to the grouping method, but we also use the product sum method. So I'm going to show you an actual example of a non-monic of how this would actually work, okay? So if this was my example of here, 15x squared minus x minus 6, I've got the steps down below this that will help guide you to your final answer, okay? So first step says multiply a and c. Recall that this is the standard formula of any quadratic expression where a, b, and c, they just represent numbers, okay? In this case over here, a represents 15, b would be -1, and c would be equal to -6. So now I'm going to multiply a and c. So I'll multiply 15 with -6, okay? If I do that on the calculator, you're going to get an answer of -90. So that's the product of a and c. Now, the second step wants you to find the factors of A and C. So in this case, list down all the factor pairs when multiplied together that will give you equal to -90. So the most obvious one is going to be 1 multiplied by -90. Another one could be -1 multiplied by 90. Another example would be 2 and -45. You could also do -2 and 45. And there's pretty much a whole list of factors that can go to -90. So I'm just going to show you in one go. So if you did this legitly, this is pretty much going to be your entire list. As you can see, this is going to be a relatively time consuming process because you guys just started learning this, but eventually you won't really need to show the full working out as I'm doing over here. Okay, so once we've actually listed down all the factors of -90, we're going to find the sum of each of these factors over here. And what you want to do is you want to select the factor that gives the sum to B. So that means when you add those two factors together, they need to equal to B. In this case, B was equal to -1. In this case over here, this is going to be 9 and -10 because 9 minus 10 gives you -1. Now, once you've actually identified which factor pairs you're going to be using, so we said it's going to be 9 and -10. Step 4 says you're going to replace B in the actual expression by the sum of the factors. So this is B over here. So instead of having -x, what I'm going to do instead is I'm going to rewrite it like so, okay? Now, what I've actually done is I haven't actually changed the expression at all. It's still the exact same expression because 9 take away 10, or 9x take away 10x still gives you -x, but I'm just rewriting it in a different format, okay? Now, I'm going to remove the brackets because we don't really need the brackets over here at all. I just purposely include the brackets just so you can see how I went from that step to this step over here. So that remember, these were your factor pairs that you've identified earlier, okay? So I'm just going to remove the brackets for now. And once we've done this, notice that you've now got 4 terms. And once we've got 4 terms, you can then start to use the grouping method that I've showed you in the previous lesson. So therefore, factorize the first 2 terms, factorize the last 2 terms together. So therefore, if you do this successfully, this is what it's going to look like, okay? Because 3x is the highest common factor for 15x squared and 9x, and -2 is the highest common factor that goes into -10x and -6. Now, once you've done this, you can clearly see that there's 5x plus 3 is the common binomial factor. So we're going to take that outside to factorize this. Therefore, our answer is going to be 5x plus 3, 3x minus 2, okay? So this is why I've said this combines somewhat both of the product sum method because you're going to find the factors and the sum adds up to B, whatnot. And then this also takes into account of the binomial, the grouping method as well. All right, I want to show you one more example over here. So this example, it wants you to state the missing numbers in this particular table over here. So I'm just going to go through the very first row. You're trying to, for this particular table, it wants you to find 2 numbers that multiply to give you AC. But I'm just going to show you the full thing and how we can actually factorize this bad boy as well, okay? So first step says multiply A and C. In this case over here, A is equal to 6, C is also equal to 6. So when you multiply them together, that gives you 36 as outlined by the table, okay? The second step says you need to find all the factors of A and C. So what 2 numbers multiplied together gives you 36. These are all the factors that will give you a product of 36. Once you've done that, what you want to do is find the sum of each, and then you want to choose the factor pair where the sum is equal to the value of B. B in this example over here is equal to 13. So therefore, we're going to be choosing this option down below. So we're going to be choosing 4 or 9, and you can kind of tell that because they already give you this value in the table. Okay, so this is just double checking again. So therefore, I'm going to be putting a 4 inside over here because 9 and 4 gives you 36. And when you add them together, that gives you 13, okay? The question, as I said, doesn't actually ask you to factorize this, but I want to show you how we would actually factorize this as well. So continue on from step number 4. What we're going to be doing is we're going to replace B. So we're going to replace 13x with the factor pair, so 9 and 4. So I want to rewrite it like this, okay? And now that I've got 4 terms in my actual expression, I can then start to group things up by factorizing, the first 2 terms together and the last 2 terms together. So if I do this, this is what my expression would now look like. And therefore, this is going to be my final answer. Okay, so 2x plus 3, 3x plus 2. All right, guys, what I'd like you to do right now is I want you to please have a go with answering this question. So I want you to find pretty much this part over here, fill in that cell, but I also want you guys to actually factorize this complete expression for that as well as this. Have a go and then compare your answers with my answers. All right, guys, if you guys have done this successfully, okay, so what we're going to do first is we're going to multiply 8 with 4. That gives you 32, obviously. And then we're going to list down all the factors of 32. So I've done so as shown down below. Find the sum of that. And what you want to do is you want to select the one that adds up to 18. In this case of here, it's going to be 2 and 16. So therefore, you'll be putting 2 and 16 in the table below. Now, if we were to factorize it, okay, we're going to split up B, the 18x, into the factor pairs that we've selected, so 2 and 16. So therefore, we're going to rewrite something similar to this. And therefore, once I've done that, I'm now going to group things up, okay? Now, notice over here that I've wrote this as 2 and 16, but I've kind of switched the order around to 16 and 2x. You'd see why later on. If you actually did this, then you'll see why I've done it in this particular manner over here. So now that I've done this, I can clearly say there's a binomial factor. If you switch the order around to 2x and 16x on the other side, you're probably not going to see that common binomial factors, which is why I've intentionally rearranged it. Now, again, if you were to factorize it, this is therefore going to be my final answer. And therefore, if you guys have done this part successfully, then in this case over here, you put negative 72 here. In this case, because it gives you negative 8, find out what number multiplied by negative 8 gives you negative 72. In this case, that's 9. And we can see that this actually works because that gives you a sum of 1, okay? Now, if we were to factorize this bad boy as well, therefore, your final answer is going to be 3x minus 2, 4x plus 3. All right, guys, what I'd like you to do right now is we're going to be answering 4 questions, but these 4 questions will take you quite some time to actually complete. So you're just going to be completing the first 2 columns for questions 2 as well as question 4. Questions 5 and question 7 is a bit more advanced. So I don't even mind if you just even do like even 3 of each, okay? But for these types of questions over here, it wants you to factorize it first and then start simplifying it, okay? That's pretty much going to be the end of today's lesson. Once you've done that, please check to see whether your answers are correct and to see whether you're on the right track or not. In addition to this, I've also developed an exit ticket. This is going to be a very easy exit ticket. There's only 6 short answer questions, and this is going to allow me to gauge what your current knowledge is to see whether I still need to reteach some of the concepts covered in today's lesson. But I'm hoping that you should be able to address the success criteria in today's lesson. If you make mistakes, don't stress about it. That's part of the process. Thank you for watching today's video. I'll see you guys again in the next video. Bye.